Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 44 in our incredible tutorial series where you are learning artificial intelligence on the Jetson Nano. I'm going to need you to pour yourself a nice big mug of iced coffee. Today I will also be enjoying some hot coffee, and I need you to get ready to learn some cool new stuff. So let's go ahead and get out our Jetson Nano gear. And as you're getting out your gear, I want to, as always, give a shout out to you guys who are helping me out over at Patreon. Your help and your encouragement keeps these great videos coming. If you guys are not helping out yet, look down in the description below. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let me jump in and talk about what we are going to learn today. What we're going to do is we are going to look at your homework assignment from lesson number 43, which was to run two cameras from the Jetson Nano at the same time. Hopefully you guys were able to scrape up two cameras. You could run two web cameras, or you could run one Raspberry Pi camera and one web camera. But hopefully you were able to scrape up a couple. I understand those Logitech cameras have gotten very expensive since the whole world is kind of on lockdown right now. I guess everyone needed a webcam for video conferencing and stuff, but hopefully by the time this video comes out, the prices have come back down and you guys could scrape up a couple of cameras. Maybe see if you could find one on eBay or something like that. But it really is, we're going to be doing things, starting to do things with multiple cameras, so it's helpful to have a couple of cameras. Let me go ahead and move out of your way now, and let's come over and let's fire up Visual Studio Code. And we are going to learn to run two cameras today, so we need to create a fresh new program. And I believe we are working in our PiPro folder. And in PiPro, we are running in our face recognizer folder. And so in that folder, I will be creating a new file. And I believe this is program 7, so I'm going to call it face recognize. And then 7, and then I'm going to call it twin cams, like that, .py. All right. Now, if we are going to run two, let me get this out of the way. If we are going to run two cameras, where's a good starting point for us to start? How about that program we have that runs one cam? So you will come over to the most excellent www.toptechboy.com. You will come down here and you will click on the little, you will want to go to starting the Raspberry Pi camera or a webcam on Jetson Nano. Search here. You can just search on web camera Jetson Nano, a couple of those keywords. You'll come here. Now you can come down and get the code. You should know this by now. We've just done this for like the last 40 lessons. Copy that code. We're going to come over here. We're going to paste the code. Okay, and now we are going to, let's fire up the Raspberry Pi camera. So I will uncomment out that, And then we always need to remember to come down here into our CV2.move window. What do we want to move? We want to move Nano Cam, and where do we want to move it? We want to move it to 0,0. All right, let's just fire this up to make sure that it runs. All right, make sure we didn't break anything, that our hardware is working. I always like to run things before I do a lot of changes, just so I'm at least always starting from something that I know that works. And I missed a comma there. You guys probably saw that. Let's try it again. Okay, there we are. All right, so now if we want to run two cameras, what's the easiest way to do that? Well, I'm going to uncomment out this second camera. And now that, for me, my USB camera is camera with a one video capture 1. Okay, but I can't have the first camera named Cam and the second camera named Cam, so I'm going to name this first one up here, the Raspberry Pi camera, I'm going to name it Cam 1, and then I'm going to name this Cam 2. Okay, and then I think the easiest thing that we could possibly do would be to come down here and read frame 1 from Cam 1, And then what I'm going to do is I am going to copy, and then I am going to read frame 2 from cam 2. Okay, so now I read a frame from cam 1, I read a frame from cam 2, and then here this first IM show, I'm going to IM show frame 1, and I will call this, that 1 was what? This was the pi cam, and then I will also CV2 IM show. I will IM show. I'll call this, this will be webcam, and that will be frame 2 that we show. And then this one we should also move, so I'll copy my move command, and I need to remember that I called this window PyCam, so I need to call it PyCam. And then I need to call this, move this window, and call this one webcam, and I don't want them on top of each other. So this is like X and Y, I do believe it's X and Y, so I will move the Y down by 640 by 480, about 500, and we should see both of these. So let's just look. This is just like the simplest, dumbest way you could do it, but let's see if it works. So I will run Python file in terminal. Giddy up! Giddy up! Look at that. We have 2 cameras going. Okay, we have 2 cameras going. It's a little bit kludgy though, and so I want to show you a little trick of how you can get a little snazzier here. A little snazzier. So what I'm going to do is I'm going to quit out of that. And then what would we like? We would really like one window with both pictures in it. So what I'm going to do is we're going to dress this thing up a little bit. So I'm going to import NumPy, okay, because import NumPy as NP, because what NumPy does is NumPy allows us to deal with pictures as math objects, as arrays, and so then we can just combine 2 arrays, and we should then have one frame that's got both pictures in it. Also, we want to kind of pay attention to our frame rate, so I'm going to go ahead and we're going to do the frame rate thing, which we learned last week. So I'm going to say import time. Okay, and then those things look good. Also, we're going to display the frame rate, so we got to set up a font. So we're going to say font is equal to cv2 dot font underscore Hershey underscore simplex will be a simple font. All right, and then also remember how we got to calculate the frame rate. So I'm going to initialize the variable dt for d is change, t is time, dt av, the change in time average through the loop, and we're going to go ahead and just set that to 0, so the first time it sees that variable it doesn't vomit. Okay, and then also if we are going to be doing, and I'm going to go ahead and get rid of those comments there, so we kind of are doing our camera setups. Now, since we're going to be timing these loops, since we are going to be timing these loops, we need to go ahead and start our timer. So I'm going to say start time is equal to time.time. So I'm going out and I'm grabbing a start time here before I enter the loop for the first time. Okay, now I read the frame, and then I show the frame, and then I move the window. But what I really want to do is I want to put both of these frames, I want to put both of the frames in the same picture. Okay, now we do that with an NumPy and NP horizontal stack, but we can't stack them unless they're the same size. And you saw that webcam was about 600 by 800, and our Raspberry Pi camera was 640 by 480. So what I want to do is I want to make both of them 640 by 480. So now one way I could do that, I need to resize the frame 2. Okay, so I would do frame 2 is equal to cv2 dot resize. What do I want to resize? I want to resize frame 2, and what do I want to resize it at? I want to resize it to 640 by 480. Now I'm not sure on that, and then I'm not sure if that should be a tuple or just two numbers, right? Or if I should have parentheses around those, but we'll just run it and see. And so what I'm going to do now, I just want to show one. Okay, so I'm going to resize it, and now I've got to stack them together. Okay, and I'm going to do that with numpy or I'm going to do that with frame combined is equal to np.hstack. So that's a horizontal stack of what 2 images? Frame 1, comma, frame 2, like that. Now what do I want to show? I just want to show frame combined, like that. And then I'll call this combo. And then I don't want to show the other one because I got them both in one. And then I don't want to move it down. And then what do I want to move? I want to move combo, like that. All right, so let me go like this, and now I'm going to run Python file in terminal. Just find my errors here. That frame 2 might have a... Okay, yeah, I got an error, and it wanted a tuple there here. So, right, a tuple would be like an X and a Y coordinate. So I would want to do it like that. So let's see if that works. Okay, so I'm going width, comma, height, and I hope that works. Okay, run Python file in terminal. Okay, still not happy. Let me make this bigger so we can see the NP is not defined. NP. I thought I imported that. Import numpy. I hate this autocomplete. I typed NP and then it put numpy in. I'm going to blame this one on them. That is not my fault. Okay, now let's see what happens. Right mouse click, run file in terminal. Okay, now what did it not like? HStack takes 1 positionable argument, but 2 were given. What is that? Okay. So HStack wants a tuple 2, okay, that it wants a tuple like that. So we need an extra set of parentheses. All right. Now, do you see what I just did? It wants a frame 1 comma frame 2 in parentheses, and that whole thing is in parentheses. Let's try this. Do you see why I like to run programs as I go? Boom, look at that. Okay, look at that. So I've got them both there. All right, let me show you one thing though that I don't like about that. If I changed this dimension up here, then this is going to break. And so what I want to do is I want to resize not to a fixed value, but I want to resize to the shape of frame. I want to resize to the shape of frame 1. Okay, I want to make frame 2 the shape of frame 1. And I'm not exactly sure what that is, and so I'm just going to print it so I can make sure that I get the data right. I'm going to look at the shape command, and so what I want is frame 1 dot shape, okay, and then I think I just do that, and it should print out the shape, and then once I see it, I'll know how to put it in that resize command. You know, we can look at the data and then see how to do it. Okay, so it's the way it does it is this is height comma width. It prints height comma width and then the number of colors, and it's a tuple. Okay, so it's a tuple, and let's quit out of this, and now let's look at this and let's make it match this. And so what the resize command is, rather than 640 by 480, I still want it inside of a tuple. So I'm going to leave that open and close parentheses there. But the first number I want is what? 640. Well, that is the second one, and 480, so we've got to switch it. Because you remember, NumPy likes to go like math people think, and like matrix people think, and it is row, comma, column. but OpenCV likes to think in X, comma, Y. And so they're in reverse order between NumPy, the way NumPy thinks, and the way OpenCV thinks. So what I got to do is I've got to say that this is frame 1 dot shape, but I want the 640. Well, that is the 1 position. And then comma frame 1 dot shape, and then the 0. So you see I've got to switch them to make it come out right. So now frame 2 is going to take frame 2 and it's going to resize it to the size of frame 1. And that way, if I ever change frame 1, the program shouldn't break. But as you probably can guess, there's a very good chance I made a mistake here. So let's look. Giddy up! Look at that! Look at that. Okay, so we've got them both working. We did it in a smart way. Let's go ahead and instrument this so we can see what our frame rate is. And so what we need to do is we need to come down here and we need to put some more stuff in to do that. So we're going to come down here, and before we show the frame, what we're going to do is we're going to calculate the frame rate. Okay, so we're going to say dt for the change in time, this time through the loop. Well, that is going to be equal to, what time is it now? Time dot time time minus start time. Okay, that's the time it was last time, and remember we did that right before we got in the loop. Okay, but now what we need to do is we need to get a new start time. This will be for the next time through. We need to go ahead and grab that so we have it for the next time through. So the next time through start time is going to be equal to time dot time. So now I've got start time that I'll use the next time through the loop. But now I need to calculate. You remember how I don't like to just use DT? I like to put a low pass filter on it. So we're going to say DT average is going to be equal to, let's say, 0.9 times the old DT average plus 0.1 times the DT that we just measured. I need to put the times in here, times the DT that we just measured, times the DTAV. You guys, in the last lesson, I talked to you about low-pass filters. What this is saying is that DT has a lot of variation in it. So my new reported value that I am going to use is not going to be the measured one because it's jumping around. I'm going to trust the old number 90%, and I'm only going to take 10% of the new number. It will always work its way up to the accurate value, to the real value, but it does it without jumping around. Watch the last video if you want more information on that. So now what I'm going to say now is frames per second is equal to 1 divided by DTAV. So if I have a 1/10 of a second to go through the loop, that means I could go through the loop 10 times. I would have 10 frames per second. If it takes me 100th of a second to go through the loop, I could go through the loop 100 times. I would have 100 frames per second. So 1 divided by DTAV will be a good approximation of your frame rate. So now what I want to do is I want to put that on my image. So I'm going to start with a background rectangle, which will be cv2.rectangle. And then where do I want to put it? I want to put it on frame combined. Okay. And then where do I want to start it? In the upper left corner, which is 0, 0. And that indeed is a tuple. And then the bottom right corner, I'll want to go over about 130 in X and about 40 down in Y. Okay, and now I'm going to make my background red, so I will go 0, 0, 255, and then I want it to be a solid box, so I'm going to put a -1 on there. Okay, I'm going to put a -1 on there. So now I should have a background rectangle, and now I need to put my text, and you know how I always mess up my put text command. Always I mess it up. I want to put it on frame combined. Okay. Where do I want to start? I want to start at, or what do I want to put? What text do I want to put? I want to put a string because it wants a string. And then I want frames per second, but I want to round frames per second to one spot. So I round frames per second to 1 decimal and I turn it into a string. Okay, and then I want to add to it or concatenate the title frames per second. And notice I put a space between frames per second so it's not jammed up against there. So I take the string, I take the frames per second, I round it to 1 decimal place, then I turn it into a string, and then I tag it or I concatenate it with the tag FPS, and that way I'll end up with something nice there. And now where do I want to put it? Well, I want to put it in the corner 0 in X, and then I want to come down about 25. I want to come down about 25 so it's not half off the screen. So I got to make sure that it's on the screen. What do I want? I want the font. I want it to be about 0.75 units high. I want it to be yellow, so I'm going to go 0, 255 of green, 255 of red, and if I combine red and green, I should get yellow if I'm thinking about it right, in a font weight of about 2, and then close that off. All right, and then let's try to run this thing. I hate it when I mess that. That put text command is the worst one for me making mistakes. Okay, what is it not like? Time. I put time. Start. No, that's right. Start time is time. What does it not like? It doesn't like 20. That's where I put time. Did you guys see that? That was kind of crazy. You probably did it right along with me, didn't you? All right, let's try this. Okay, boom. So you can see that we're running at about 16 frames per second. I've got both images in the same window. Giddy up. Giddy up. We're getting this looking good. All right. So now, what do we like? We're running 2 cameras. Okay. What do we like? The cameras are running kind of smoothly. What do we not like? Tell me what we don't like. Look at the video and tell me what we don't like. Okay? Class? Type down below. Tell me what we don't like. All right. What you see is, you see that our problem is that our videos are out of sync. Okay? And so the one on my right is the webcam, and you can see that the Raspberry Pi camera is like a good second behind that. Now, why is that happening? I mean, what I like is they're both smooth, but you just can't live with that kind of latency with the types of things that we're trying to do. And this is kind of the problem if we come up and we look at our code, that while we're out and we're reading, like let's say while I am out reading, and also these 2 cameras are working at 2 different frame rates, okay? And so the Raspberry Pi camera is working at 21 frames per second, and on the webcam, I don't know what frames per second it's running at, because I can't go out and I can't read that and set that using GStreamer. At least for this ELP web camera, I can't interact with it like I can interact with the Raspberry Pi camera. So I'm just getting the frame rate that I'm getting. Well, what if the webcam was operating at, let's say, 15 or 16 frames per second, and the Raspberry Pi camera is running at 21 frames per second? When I go out to get a frame from the webcam, it might have to wait on it. And while it's waiting on it, frames are coming from the Raspberry Pi camera. And so what that Raspberry Pi camera is, it is not being read quick enough, and it is stacking up data in a buffer. And so then when you go read from it, you're reading old data, or you're losing frames. So you see, you can't just randomly go out and say, okay, I'll work with this camera and I'll work with this camera. Now, what is the good news? The good news is we've got 2 cameras. they're working. It's kind of good that we know all of that. But the problem is for us to really start moving forward and doing these things the way that we need to do them, we've got to learn more about Python. Okay, and the way that we've been working with Python in the past is we've just been working very logically. If I want to read the camera, I read the camera. If I want to display it, I display it. So I kind of make a grocery list of all the things I want to do, and then I go in and I give commands to do those things. And that's kind of like a really logical way to program. But you can see we get to the point that that just doesn't do it anymore. So what we've really got to learn is we've got to learn 3 things in order to move forward. So in the next lesson, lesson number 45, there's going to be like 3 things we've got to learn. We've got to learn how to do functions. Okay, that's where you give a call. You write a function and then you call a function. And so rather than doing a lot of code, you create a function and then you call the function. We've probably done that in the past, and so you understand how to do functions. Okay, what we're going to have to learn that you probably haven't done is classes. Okay, a class is like an entity. It's like a little toolkit, and that toolkit of a class will have data in it and it will have functions. When you put a function in a class, you call the function a method. And so it's kind of like a little toolkit where you have data and you have functions, but now we call them methods. And so maybe I have this little class that I'm going to call a box, and that box can keep things, data like the size of a box, and then it can keep things like calculations, like how to calculate the area, how to calculate the perimeter, and the perimeter. And so we would put all that inside of a class. Now, what makes classes confusing? If you've ever seen other people's code and they define a class and then they start saying init and start saying self and start saying all this, it's just like it's completely crazy. Well, I'm going to take you through in the next lesson, and I'm going to make it where you understand classes. Okay, so you're going to understand functions. You probably already do. We're going to then understand classes, and then once we know functions and classes, we're going to have to talk about threading. And what threading is where you're multitasking, where you're doing more than one thing at once. So we're going to start a thread that is reading camera 1, and it's over here reading camera 1, and then we're going to start a separate thread and we're going to read camera 2. So this thread is running on its own, this is running on its own. So if they're running at different speeds, that's kind of hard to show different speeds, but if they're running at different speeds, this one, the fast one is not waiting on the slow one. They're operating independently. So that's what we're going to do in the next lesson. We're going to learn functions, classes, and threads. And then we can do this type of program up here where they will be running in sync. And then moving forward, we can do a lot better job in the programming that we're doing. Okay, hopefully this program has shown you the need for becoming better Python programmers, and then we will do that in the next lesson. Okay, guys, really appreciate your help on Patreon. I really am encouraged to able to get that help. Keeps me in premium coffee beans and also helps me get the gear that I need to make these videos. Okay, Paul McWhorter from TopTechBoy.com. I will talk to you guys later.